Hello and welcome to another video. This one is going to be a little bit more complicated than our usual video. I wanted to explain in detail how nametuple works in Python. And well, the easiest way to do that for me is to actually implement my own nametuple and kind of show you how I would go about building things. The actual implementation has, a little bit more complicated stuff than what I'm going to show you, but I'm going to show you just kind of a basic implementation of that. So let's jump into it. Now, I say basic, but we're going to be using a lot of kind of advanced concepts here, so if some of this stuff doesn't make sense, just let me know, and then I can, make more videos about it. We're not going to do this form of nametuple. We're going to try and simulate the old collections.namedtuple because it's a little bit more simpler. This type of nametuple actually goes through metaclass hackery, and I don't really want to write a metaclass for this, so we're just going to make our own make named tuple function, and this function is just going to take in the class name as well as the fields that we're going to use. So class name and fields, and it should return a class back when we're done. And there's kind of, well, the main way that you build a class at runtime in Python is by invoking type. So at the end, we're going to do return type, and type takes 3 parameters. The first is the class name, which fortunately we have right there. The second parameter is the list or the sequence of base classes. In this case, we're going to extend from tuple because it is a tuple, so it's extending from tuple. And the last is a list or a dictionary of attributes. We're going to fill those out in a second. We can start by putting in the most basic one, which is the fields attribute. So let's just start with this, show you what we have, and I'm going to rewrite this user equals make name tuple with user, and the fields are name, age, and location. We're not going to be using that. We'll also do this as well, and we'll reestablish slots here. So this is not going to work currently, but we're gonna make it work eventually. So if we do for user in get users, print or user dot print me. This is the code that we had way before, and you'll see here that we immediately get a problem that says tuple expected at most 1 arguments got 3, and this is because the initialization of tuple requires a sequence of things, and we're passing in positional arguments instead of a sequence. So the first thing that we need to do is we need to customize the initialization, and I couldn't figure out, I thought about this for a while and I couldn't think of a way to do this dynamically just using Python code. And so the easiest way that I could figure out to do this is by abusing exec, and make the initialization. And so the way we're going to abuse exec is a new method. We're going to make a string, and we're going to evaluate that string. Now, in this case, we're going to use double under new instead of double under init, and this is because we want to create an immutable object, and we're going to mostly be doing that by returning the base class. Usually, you don't define double under new in classes yourself. There are of course a few exceptions to that rule, and most of the time you'll use double under init for your initialization. But the signature that we want today is to have all of these as positional arguments instead of as single arguments. And so we're going to turn this into an f string, and we're going to comma separate these. We're building code here, which is a little bit sketchy, and yeah, this is, I would probably do a lot more validation on these inputs here, because just running exec blindly on parameters here can lead to security issues. Exec is one of the unsafer functions in Python. But we can just do this directly, and so this is going to turn into double under new class, and then in our case, name, comma, age, comma, location as positional arguments here. And we need to, the first thing we need to do is we need to initialize tuple, and the way we're going to do that is by calling tuple.doubleUnderNew. This is going to initialize the tuple object, and we're just going to return this directly because we don't need to do any other special customization after this. But we do need to pass these 3 fields as a sequence. And so we're going to make a tuple in here, and we're going to put those fields in here. And so this, if we print new method now, print new method, when we run this code now, you'll see that this is the, oh, of course I made a mistake. Gonna have to have one extra parenthesis there. This is the new method that we're going to try and exec and turn into code here. So we'll call that new method S. I'm gonna use exec here, and we're going to exec new method S, but we're gonna make it right into our adders dictionary up here above. So we're gonna pass in adders as the second argument of exec. And now if we run this, oh right, we're gonna get rid of Carmen Sandiego for now. Now if we run this, it kind of gets a little bit further. You can see that, we are able to initialize these 3 users, but we're not able to initialize Carmen Sandiego because we didn't do the whole defaults thing. We could do the defaults thing, but I'm gonna leave that out for this because it's gonna make this a little bit simpler. Okay, so now we're actually building objects properly. So if we do this now, we can say, user Anthony, ignore the error. We can make a user like this. The user still looks like a tuple, but the type should be our custom user type. Yeah, so you can see it's our custom user type. So we're getting closer to having this working, but we don't have the individual attributes working. But the way that we can make the individual attributes work is we can create properties for each of them. So I'm going to make a make named adder getter function, and this is going to take in an index because we're going to actually index into this tuple. Like user 0 is our name, user 1 is our age, and user 2 is our location. So we're gonna make a function that returns a function that returns the right index in self. So if we'll do index, this is an int, this is a stir, and this is going to return, well, it's going to return a property. Never mind, we're not going to type annotate this. Annotating a property is kind of a little bit tricky. But we're going to make def getter, and this is just going to take self, and it's going to return self idx. And we can decorate this directly. Well, actually, let's change the name first. So getter dot double under name is equal to name. This is just so if you ever see this in a stack trace, it'll have the proper name here. And we're going to return property getter. This is again shorthand for doing, at property def whatever your name is, self return self idx. So this is kind of what we're trying to build as part of this function here. But of course we can't, dynamically do this, so we're reattaching the name here, and this syntax, this at syntax is syntax sugar for this. I'll link the video on decorators as well in the description because I go into depth about how decorators work, and I'll link the video about properties as well because I have videos on that as well. And so the next thing we're going to do is we're going to use this function that we just wrote to create all of those named properties. So for idx name in enumerate fields, we're going to do atters name is equal to make named adder getter idx name. So this will allow us to create a bunch of properties for each of those fields, and they will access individual slots inside our class there. So if we do this now, we should actually get it to the point where it can run our sample code. Yeah, so now our sample code is working. There's a few other things that I would probably do to improve my name tuple implementation a little bit. The first is like we don't have, asdict, we don't have, any of the nice reppers. Like if you do user Anthony 29 CA, you'll see that, we still get the tuple representation back, so we probably want to make our own repper. And we can do that pretty easily. How would I do that? What's the easiest way? We can probably just do name tuple repper self, and this should return a string. We can access self.fields because we passed it in here. Let's see, fields s equals comma dot join name equals getter self name for name in self.fields. Yeah, so this will get us hopefully a explanation of each of the attributes, and then we can do return type self.name with fields s. And we'll also add that into our attrs here. So repr will be name tuple repr. So hopefully if we restart this now and we build a user, yeah, you can see now, oh, not quite what we wanted. We want to make sure that this is the representation here. So we'll do bang r. Yep, and you can see now we've replicated our representation there. You can now see that, you know, when you construct a user, it tells you about your various named attributes there. And of course, I could add more and more of the various methods. I could add asdict, etc., etc. But most of the magic in name tuple can be, you know, summed up in these lines here. I know this was a lot. I know I went over a bunch of different concepts here, so that's why I'm marking this video as advanced. But oh, actually, one other thing that I wanted to kind of talk about here is how this class would look like if I had written it out manually by hand instead of generating it like this. And so let me do that really quickly. It would look something like this: class user tuple. So we're extending from tuple. We would define double under new as class and name, age, location, and we return tuple.new class name, age, location. We would have a property for name, and that would return self 0. We would have a property for age, that would return self 1, and we would have a property for location and self 2. We would have a repr, which would return type self.name, and then name equals self.name, age equals self.age. And of course, this is not going to fit nicely on one line, so let's put this on another line. And then location equals self.location. And this is kind of what that class that we generated looks like. I guess you would also have, you know, fields equals name, age, and location. That's kind of what this class would look like if we had written this out manually by hand instead of generating the class. But yeah, again, hopefully this was useful. If you guys have additional stuff you want to see, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you guys in the next one.